Welcome to my Chapter 11 Network Address Translations for IPv4, and this is for my Routing and Switching Essentials course. This happens to be our last chapter in this section. So without further ado, let's talk about Network Address Translation, also known as NAT. This chapter focuses heavily on NAT operations, configuring, and troubleshooting NAT. NAT is pretty straightforward. NAT is the ability to take one address or a range of addresses and allow that to be the mask of a network, a single device, a range of devices, or really just depending on how you configure it. So we're going to talk about different characteristics. I'm going to talk about the benefits as well as the drawbacks, how to configure static NAT, also known as one-to-one, or dynamic NAT. We're going to look at patch, which is slightly different than NAT. We're going to look at port forwarding, and we're going to look at some NAT64, as well as ending with some troubleshooting with our show commands for NAT operations. So without further ado, NAT operations. So first thing we have to do before we get into NAT is realize that the IPv4 address space isn't big enough for everyone to have unique addresses, so especially on the internet. So what we had to do was we had to have some way of taking private addresses and disguise them so that they could get on the internet. Because remember that a private address is not routed on the internet. Public addresses are. So NAT takes the ability in general to take a single or range of public addresses and allows us to take a group of private addresses and NAT them to those public addresses. That way, on the internet side, we see just a public address or a specific range of public addresses. But in reality, behind those are all of our public. Behind all of the public addresses is all of our private addresses. So that's why at home you're allowed a 10. Address or a 172.16 address or a 192.168 address. Those are all private addresses. And that's not your real IP on the internet. Normally your ISP will give you one public address and all of your home devices will be NATed to that public address. So part of this process is the translation, and that is being able to translate between both private and public address and having a mechanism in place that can do that. And that is the point of NAT. So NAT router allows us to take an internal network or private addresses and mask them through a NAT mechanism so that those addresses now become masked with the NATed address. So we can have one or a range of addresses that are public or internet routable, and we can mask our private addresses to one of those. Now remember, our private addresses as defined by RFC 1918 is anything between 10.0.0.0 through 10.0.255.255, or if we have a class B, 172.16 through any 172.31 network, or class C, 192.168 through 192.168.255.255. So those are our private addresses. So what is NAT? And again, NAT is the process used to translate those private addresses and public addresses. NAT's primarily used to conserve public IPv4 addresses. NAT is usually implemented at a border device. You can NATed addresses, and you can actually take that pretty dang far. NAT allows the network to use private addresses internally while using a few or a single public address to get on the internet. So there are some NAT characteristics that are kind of important. So graphically, how does that work? We can actually have this as all private address space, and only when it leaves R2 as an egress to our ISP, then it will be NATed. And what will be NATed? It will be NAT. All packets leaving this network heading to the ISP will be NATed. As it comes back into R2, it'll be decapsulated and then translated back to the original private IP address. So, NAT terminology. Inside local, inside global, outside local, outside global. Those are the key concepts for our NAT addresses. Alright, so an inside local address. That is the IP address assigned to a host on the inside network. This is the address configured as a parameter of the computer or received via DHCP. This address is not likely a legitimate IP address, meaning it's not a public address. That means it should be a private address. An inside global address is a legitimate IP address assigned by the NIC or to the NIC or service provider that represents a one or more inside local IP addresses to the outside world. A public address. Outside local address. That is the IP address of an outside host as it appears to the inside network, not necessarily a legitimate address. It is allocated from an address base routable on the inside. Lastly, outside global addresses. Those IP addresses are assigned to a host on the outside network by the host owner. The address is allocated from a globally routable address or network space, a legitimate public address. So again, local addresses is any address that appears on the inside portion of the network versus a global address, which a global address is any address that appears on the outside portion of the network. Alright, so let's look at an example of this. So, from PC1 to our web server, our source address is 192.168.10.10 because that's our PC's IP. Our destination address is 209.165.201.1, and that's going to be our web server. Our inside network, our outside network. Notice again our source and destination, both inside local and our outside locals, because this is the address that we want on the outside. However, from the outside, our inside global looks like 209.165.226, because that is our outside interface. That's the mask address. That's what we're hiding everything behind. That way, the web server will respond to PC1's request. It will come back in, and the router itself will do the translation between this 192.168.10.10 address and this 209.165.226 address. Here is our breakdown for our inside global, inside local, outside global address. So static NAT. Static NAT uses a one-to-one mapping for a local and global address. This is where you may want a specific resource internally, also accessible externally. These mappings are configured by the network admin and should remain constant. Normally, again, it's when you have a network service internal that you want allowed outside access. Normally I do this for like VoIP servers or file servers that require outside access, or that I want to be able to access them externally, or gateway addresses or remote gateways, things like that. And so what we can do is we can NAT, for example, this 192.168.10.10. This will always be responding on that address. even though this router may have a range of addresses, this one is mapped specifically to that guy. That way, whenever you go to this address internally, it always goes to that guy. Versus dynamic NAT. Dynamic NAT uses a pool of public addresses and assigns them on a first-come, first-served basis. So when an inside device requests access to the outside network, Dynamic NAT assigns a available public address. Dynamic NAT requires that you have enough public addresses to satisfy all of these simultaneous users. That's more subjective because if you only have one public address, you can NAT them based on ports, but that's more complex than our initial conversation. And so what will happen is any PC will get a range of these addresses. It happens to be that 10.12 needed the resource, so it'll be assigned temporarily that address. But as more things happen, they will get a random address within that pool, because you will define the pool of addresses when you do your initial configuration. So let's talk about port address translation, or PATS. And PAT will map multiple private IP version 4 addresses to a single public address, or fewer addresses. You can't really have fewer than a single public address, so that's kind of weird. But PAT uses a pair source port and source IP address to keep track of what traffic belongs to what internal client. So this is where the ports will come in. PAT is also known as NAT overload. That is where we can take one public address and we can overload it to have multiple private addresses behind it. By also using port numbers, PAT will forward the response package to the correct internal device. So let's compare NAT and PAT. NAT translates IPv4 addresses on a one-to-one, where PAT does not. PAT modifies both the port and address. NAT will forward incoming packets to the inside destination. PAT will normally is overloading, so we have multiple addresses. PAT is able to translate protocols that do not use port numbers, such as ICMP. All of these are randomized ports. Benefits of NAT: it conserves the legal registered address scheme. Basically, it conserves our public addresses. It increases the flexibility of our connection, provides consistency and security. NAT providing security, that way you don't know how many private addresses you have behind a NAT router, so that's one of them. Disadvantages: performance. You do not have end-to-end functionality, meaning end-to-end host communication no longer happens, because again, private addresses are not routable on the internet. Makes things like tunneling more complicated, and initiating TCP connections, you can disrupt them. So let's go on to how do we configure our NAT. So for the configuration, there's a few basic things that we can do. We need to create the mapping between the inside local and outside local addresses, and we need to define which interfaces they belong to. So how we do that is IPNAT inside source. If we're doing a static, it'd be static, the inside address space the outside address. So that would actually define our one-to-one static NAT. And what you'd also want to do is you would actually want to do this IPNAT inside and IPNAT outside, so it knows where to be translating these addresses at. That way, if it knows if it's coming from this way, it'll be coming in to. So that means this interface will be the outside interface. So that will be the outside interface. And that one will be the inside That way you know kind of where to put IPNAT inside, IPNAT outside. That way it knows where the translation has to occur. So how does that really work? Is it will take the source address and it will send it through the internal network all the way in here. Once it enters the inside interface, it will then translate it to the outside global address, and when it leaves, it will have the outside global address. So how can we show to make sure this is functioning? We could do a show IP NAT translation, and you should be able to see the inside global address and the inside local address. During an actual active session, you will get, again, the inside global, inside local, but you'll also get the outside local and outside global address. These are only there for active sessions. So if you want to clear the NAT stats, you can do a clear IP NAT statistics, and that will clear all of the statistics for your NAT. If you want to see them, you could do a show IP NAT statistics, and you'd get that. So that's for static NAT. But what about for dynamic? For dynamic, you have a pool of public addresses. With dynamic, you have a single inside address that will translate to a single outside address. So the pool again must be large enough, unless we're going with NAT overload, also known as PAT. So for basic configuration for dynamic NAT, define a pool, and for that you'll do IP NAT pool, the name, the start and end range, the mask or prefix length. You'll configure a ACL permitting the addresses that should be translated. You'd establish a dynamic source translation, so IPNAT inside source list, access list, pool, the actual pool name, and then you'd be applying them to interfaces. So again, pool, ACL, you map the pool and ACL, and then both of these are setting up NAT for inside and outside translation. So analyzing dynamic NAT, again, they're going to be, if it's all dynamic, first come, first serve. So as these sessions are active, they'll just be cycling through this pool of addresses. And then when they return, again, they'll come back to the NAT router and they'll be translated back into their internal network address, because during this active session these will be mapped so they'll be equal. That way, once a session is terminated, these addresses go back into the pool for the next person able to use them. So how can we verify dynamic NAT? Again, we're going to do a show IP NAT translation, or we're going to do a show IP NAT translation verbose. That way you can kind of see more detail. Just like anything else, we can clear the IP NAT statistics, or we can view them just like we did with static NAT. Alright, moving on. How do we configure PAT? PAT's pretty similar to dynamic NAT, except we have the ability to overload, so we could have a single address. So again, first thing we do is we set up our pool. IPNAT pool, pool name, start address, end address, and the net mask. Now the start and end address could be the same if we only have one public IP address, so keep that in mind. Next step, set up an ACL. Third step, map our source list and our pool. That way we know what addresses can access that pool. Lastly, we apply NAT to our interfaces inside and out. So if we want to configure PAT as a single address, what we do is pretty similar. You could do it the way we just did it, or we can actually remove one step. And here we're going to set up our ACL instead of our pool of addresses. We'll just start with our ACL. Then step 2 is we're going to map our ACL to our pool. But we didn't set a pool. That's okay. So what we do is we do IPNAT inside source list, our ACL. Here we do interface, the type and number, and we use the word overload. And so what we'll do is we'll take that interface, we'll use that IP address, and we'll overload that IP address. And again, we do our NAT inside and out for our interfaces. So here, we're combining the creation of our pool plus assigning our pool an ACL and mapping them. Because again, here we're only using a single address, so we could use the interface address without having to do a pool of addresses. So patch, again, it will randomize the ports. That way, coming back in, it knows that this port is associated with that address. It knows that port is associated with that address. That way, it knows how to return or where to return the appropriate packet. And again, it will be responding with a destination port, and we've already talked about those being mapped to that address. So verifying PAT translation, show IP NAT translation, and you'll be able to see your inside global, inside local, outside global, and outside global. Now remember, active sessions, get these. If they're not here, we don't have any current active sessions. So that's our NAT and PAT in a nutshell. We have a few more things to talk about, so we're almost done. And one of them is called port forwarding. And port forwarding is pretty similar to NAT/PAT, but here we're going to forward just a specific port to an address. And this is normally done for small home offices, also known as a SOHO. That way we can map a specific port to an internal address. So here we have a web interface for, I'm going to assume is a Linksys address or a Linksys router. And so it's basically going to say anything coming in from the internet to our router on port 80, send directly to my internal address. That's why we have an external port, an internal port, and where we want to send it to. So anything coming in on this port, translate it to that port and send it directly to that location. If we want to set this up using Cisco IOS, again, pretty similar stuff. We can do IPNAT inside source. We're not going to be doing a list. It will set up a static address or a static forward protocol, internal port, external address, external port. And then again, apply NAT to the appropriate interfaces so it knows where the translation will occur. That way, anything coming in on port 8080 will automatically, once it comes in, will be forwarded to that port and will be translated or sent directly to that address. So NAT for IPv6. So NAT was the IP version 4 workaround for address scarcity. IPv6 has 340 undecillion. That's kind of a lot. Undecillion should be greater than a decillion, non-million, octillion, sep, sex, quin, quid, trill, bill, mil, 1,000 addresses. So we're talking a lot of addresses. So we don't need to worry about address scarcity with IPv6, so NAT really isn't there. IPv6 does have unique local addresses, and they are designed to allow IPv6 to communicate within a local site, i.e., not on the internet. These unique local addresses are not meant to be provided additional IPv6 address space, and they should have a prefix of FC00::7, meaning they're only using the first 7 bits, which means we have the first range of addresses between FC00 and FDFF. These are also known as local IPv6 addresses, and that is not the same as link local addresses. Keep that in mind. NAT for IPv6 again. IPv6 also uses NAT, but in different contexts. NAT is used to provide transparent communication between IPv6 and IPv4. NAT 64 is not intended to be a permanent solution. And there's also other types of NAT functionality for IPv6 to 4. There's also NAT protocol translation, NAT-PT, which is another NAT-based translation mechanism. But nowadays, it's all about NAT64. So NAT for IPv6. Again, that way we can translate or send packets between 4 and 6. Last section, let's talk about troubleshooting our NAT. There's going to be mappings. So sometimes we want to see the translation. Sometimes we want to clear the translation. So we can clear the translation by doing clear IPNAT translation. Or if we want to look at the statistics, we could be looking at just the statistics. If we need to clear the stats, we'll do a clear IPNAT statistics. We could also do a debug IPNAT, and that will show you the specific source and destination, the specific mapping of addresses. And that's it for chapter 11. I wanted to thank you guys, and hope you guys have a great night. Thank you.